Hi there, myself Madhav Jha. I welcome you to CodeChef and let's have a look at this question.
The problem is sorting prefixes. The problem difficulty is easy and there are no prerequisites. Let's have a read at the problem. You are given an array A which is permutation of the integers 1 to n. Your task is to sort the array using the following operation as many times as you want. The operation is as follows. We can choose the index I and then it will cost us AI coins to sort the prefix going from 1 to I of the array. Note that the cost is levied before the sorting operation is performed. Here, when we say prefix till I, we mean all the elements A1, A2 till AI. We need to find out what is the minimum total cost to sort the array. For the input format, we have t test cases, and for each test case, we have two lines. The first line contains the integer n, and the second line contains n-spaced integers. Those are a1, a2 till an. As for the output format, we simply have to output the minimum cost to sort the array. As for the constraints, number of test cases will go from 1 to 100, so will the length of the array and the elements as well. Let's see some sample inputs. So for the first sample input, the array has three elements and they are 1, 2 and 3. Since they are already sorted, we do not need to perform any operation. Therefore, the answer is 0. As for the second sample input, the elements are 3, 2 and 1. So what we'll do is, we'll choose the last element. This will cost us 1 coin and this will sort the complete array. Therefore, the cost here is 1. Similarly, for the third sample input, we have 5 elements and they are 2, 3, 1, 4 and 5. Now, if we had a sorted element of the same array, it would look something like this: 1, 2, 3, 4 and 5. Now, as you can see, the last two are already sorted. So what we'll do is, we'll choose the third element. With this, we will sort the starting three elements and it will cost us again only 1 coin. Therefore, the answer is 1 here. Let's see how we can approach the solution. So as we have seen, the length of the array is just 100. So what we can do is we can first find the sorted array. So let's take the example of the last sample input where we have 6 elements. So without any sort of sorting, the elements is 2, 1, 4, 3, 5 and 6. Now if we sort it, the elements will come 1, 2, 3, 4, 5 and 6. This operation will cost us n log n, right? Now once we have this sorted, we can start checking from the last element. So 6 is at the correct place, same goes for 5, but 3 is misplaced. So what we will do is, we'll choose this index and sort all the elements starting from the very first element to this misplaced element. With this, what will happen is, this complete prefix will be sorted, and after this, since we already have sorted elements, the complete array will become sorted. Now why is it that we are choosing from the last? Because let's assume if we had chosen this one because it is low cost, it will only sort 2 and 1. 4 and 3 will still be unsorted. At the end, we'll be forced to choose 3 again. And if we choose 3, we are anyway sorting the complete prefix. So it makes sense that we choose the farthest index from the start when we're trying to perform this operation. So we'll have a sorted array, then we'll compare from the end to find the first element that is not as per the sorted. Once you find that, we'll perform the operation till that index, and that will be our cost. And with this, we'll find the minimum cost to sort the array, and this will give us a solution. Let's see how we can implement the solution in C++. So for each test case, we call the function solve. In solve, we take the input of our array. Then we create a temporary array. We sort one of the arrays and then start checking from the last index coming to the first. We'll check at which index these two arrays differ. That we will pick that index to perform our operation. Once we do that, all the elements starting from the very first element to this mismatched index will be sorted. And the cost to perform this operation is the value of the element at this index, and that is our final cost. And with this, we'll print the minimum cost required to sort the complete array. And as you can see, I have AC in my C++ implementation. Let's see how we can implement this in Python. Again, for each test case, we call the function solve, take the input of n, then our array. Then we form a temporary array that is same as our original array. We sort our original array and then find out the first index starting from the end that is not same, that has not the same values in both of the arrays. Once we find that index, we will perform the operation from start till that index, and the cost is the element that is at that index. And with this, find the minimum cost to sort our array. And as you can see, I have AC in my Python implementation as well. So I hope you understood the problem, the approach, and how we can implement the solution in both C++ and Python. Have a very good day, and I'll see you in the next video.